Hi second year students, my effort to solve exercise 1.3 from the Federal Board Punjab Board. Evaluate the limit. For limit, let me give you a simple and once for all a final advice. Put direct limit. If denominator is not 0, then it's our answer. If denominator is not 0, then it's our answer. For example, here denominator is 0, 2 minus 2, we cannot put direct limit. Here 1 minus 1, denominator is 0, we cannot put limit. Here minus 1 plus 1, we cannot. On the other hand, if there put 3, 2 times 3, 6 plus, there is no denominator, there is no concept of 0 in the denominator, then it's our answer. There are traditionally two broad categories of limit. One is any real number, 1, 2, 3, pi, pi over 2, 2 pi, 3 pi, whatever the case is. And the second one is infinity, going towards positive infinity or negative infinity. It is a case of based on real numbers. Real numbers. Put direct limit. If denominator is not 0, then it's our answer. If denominator is not 0, then it's our answer in that case. That's the evaluation of limit. Question number 1. Limit x tends to 3, 2x plus 4. What we have to avoid in case of a real number limit? Real number means 1, 2, 3, 5.2, 60, 70, whatever the case is. A real number, a real number, a real number. Put direct limit. If denominator is not 0, then it's our answer. There is no concept of a denominator. Just put direct limit and it's our answer. 2 times 3, it will become 6 plus 4, 10 is our answer in that case. 10 is our answer in that case. Question number 1. Similarly, in second one, there is no concept of denominator. Let me evaluate this for you. A simple warm-up exercise in limits. 3x square minus 2x plus 4. What we have to avoid? We have to avoid 0 in the denominator. 0 in the denominator. There is no concept of denominator. There is no denominator. It is a polynomial type function. Limit exists in polynomial type of function and they are continuous everywhere. They are continuous everywhere. Put limit here. 3 times 1 square minus 2 times 1 plus 4. Just simply evaluate. Just putting value. 3 minus 2 plus 4. 6, 7, 7 minus 2, 5 is the answer in that case. 5 is the answer in that case. Similarly, take 3, 1 of warm up, just put direct limit because there is no denominator and it is not going to be 0 after putting. Here, there is no concept of denominator, put direct limit. X 3 square plus 3 plus 4, it will become 9 plus 3 plus 4, 16 I think. 16 is the perfect square of 4. 4 is our answer. Similarly, question number 4, just keep on putting limits. It's a little bit warm up for you, but try to grasp whatever I want to say. In case of limits, limit has two broad categories based on real number 1, 2, 3 pi, 0.2, 2 pi, 3 pi, whatever, and second one is infinity. Here in the frame, all are real numbers, 1, minus 1, 0, 2, whatever the case is, just put direct limit. If denominator doesn't 0, then it's our answer. In that case, x limit is 2 times root 2 square minus 4. 2 square of 2 is 4, 4 minus 4, 2 times 0, it is R0. It is R0. It is also a defined form, not indeterminate form. Similarly, 5, limit x tends to 2. Similarly, x tends to root x square plus 1 minus root x square plus 5. Look at this, there is no denominator, put limit 2 square means 4, 4 plus 1, 5, 2 square, 4, 4 plus 5, 9, and it's our answer. Just put value. We are practicing just function value at x is equal to like 2 square plus 1 minus 2 square plus 5, it will become root 5 minus root 9 and it is equal to root 5 minus square root of 9 is 3. That's our answer. That's our answer. That's our answer. Pass me the duster if you mind. if you don't mind. Yes. Question number next, based on denominator. Now we are getting into our territory where we have to take care of the denominator and the real questions in sense of limit. Here it is 6. Part number 6 of one, limit x tends to negative 2, 2x cube plus 5 times x over 3x minus 2. Look at this. Just check the denominator. If there is a denominator, there is a denominator. Go ahead. 3 times minus 2, it's minus 6. Minus 2, minus 8. Denominator is not 0. Denominator is not 0. It is our determinate form. It is our determinate form, defined form. Just put limit. We have to avoid 0 in the denominator. 2 times minus 2 cubed plus 5 times minus 2. Overall 3 times minus 2 and minus 2. Cube of minus 2 is minus 8. 5 to the 10 plus minus 6 minus 2. It will become minus 16 minus 10 over minus 8. Minus 26 over minus 8. Applying table of 2. 13 over 4 if I am not wrong. 3 to the 6. Minus 6 minus 2 is minus 8. 8 to the 16. 2 5 the 10. Minus 16 minus 20 and so on. That's our answer. We have to avoid 0 in the denominator. 0 in the denominator. Our real exercise starts from 2. Real exercise starts from 2. It's stretching the muscle, just warming up, just a little bit jogging for limit. Now, question number 2. We are on a driving seat. Be careful how to evaluate limits. Let's see in real sense. Limit. First part of second question. Limit x tends to minus 1. Some people read that x tends to minus 1, x approaches to minus 1. It means we are approaching towards minus 1, but not exactly x is equal to minus 1. X cube minus x over x plus 1. If I put direct limit here, it will become minus 1 plus 1. 0 in the denominator. It is indeterminate form. It is indeterminate form. We have to avoid this. We have to avoid this. At our second year level, try to take something common from the numerator if possible. X common, we have x square minus 1 overall x plus 1. Still x square minus 1, suitable situation to apply a difference of 2 square technique to factorize. Limit x tends to minus 1, it is x times x plus 1 times x minus 1. Factors of x square minus 1, there is x plus 1. Cancelled out. We are going to have something like this. X tends to minus 1, x times x minus 1. Now, there is no more denominator. We take a sigh of relief. Just put limit direct. Now, minus 1, minus 1, minus 1. X means minus 1, minus 1. It will become minus 1 times minus 2. Positive 2 is the answer. Positive 2 is the answer. It is our little bit question in the real sense. We have to avoid overall 0 in the determinant. Overall 0 in the determinant. If overall determinant is 0, then it is indeterminate form, undefined form, undefined form. We have to remove this indeterminacy. Moving towards next question. It is also our limit x tends to 0. Question number 2, part number 2, limit x tends to 0, x approaches to 0, x going towards 0. We have 3x cube plus 4x overall x square plus x. Let me check the data. 3x cube plus 4x, we are good to go. Put limit, look, check the denominator, 0 square plus 0, it's overall 0. Indeterminate form. Indeterminate form. We have to avoid 0 in the denominator. Just simply check something common from numerator as well as from denominator. Situation lightens and we are going to get through. Limit x tends to 0. X common from the numerator. It will become 3x square plus 4. Taking x common from the denominator as well. X times x plus 4, 1. cancelled out. Now we have lightened ourselves. We have limit x tends to 0. It is 3x square plus 4 overall x plus 1. Now check, put limit x plus 0. X is 0, 0 plus 1, it's 0, 0 plus 1, 0. So denominator is not 0, we are safe to apply limit. It is r 3 times 0 square plus 4, 0 plus 1. At 0 we have 4 over 1, 4 is our answer in that case. 4 is our answer in that case. We are now roaming in the vicinity of real limits. Question number 3. Question number 3. Part number 3 of question number 2. Limit x tends to x cube minus 8. X cube minus 8 over x square plus x minus 6. Question number 3. Limit x tends to 2, approaches to 2, going towards 2, x cube minus 8 overall, x square plus x minus 6. There is the denominator, just check denominator. If it is not 0, it's our answer. If denominator is overall 0, then we have to avoid that situation anyhow. X is 2, 2 square plus 2 minus 6. It will become 2 square means 4 plus 2 minus 6. 6 minus 6. Indeterminate form. Bell of the danger. We have to avoid. Look at this. If we inspect the situation, cube type, a cube minus b cube factors are possible, and here the middle term breakup. Apply this situation. Lightens the data. X tends to x cube. 8 can be written as 2 cubed overall x square. 3 to the 6. If we subtract 2 from 3, middle term breakup is also possible. Or trinomial type. 3 times x minus 2x minus 6. Look at this. I have taken 1 and 6. 1 times the 6, 6. From 6, I want 6. I want positive x. I want positive x means only 1x. I have written 3x minus 2x. Look at this. Check here. Plus 3x minus 2x. I am going to have same positive x. Cube type factors. Limit x tends to 2. We have first bracket without cube. First bracket without cube. Square of first. Change the symbol. First into second. X times 2 plus square of second or last 2 square. Overall, x common. In denominator, x common. X plus 3 minus 2 common. Whenever we something negative common, we have to change all upcoming symbols. It turned to be positive, it turned to be positive. X as well as 3. Look at this. These two brackets are identical. We are good to go with trinomial type. Limit x tends to, we have x minus 2 times x square. It can be written as 2 times x. Square of 2 is 4. Overall, one bracket is x plus 3. The other one is x and minus 2. X and negative 2. Cancel out this bracket. What remains? Just write down. Limit x tends to, we have x square plus 2x plus 4 overall x plus 3. Bingo. Put limit 2 plus 3, 5. Denominator is not 0 and we have done work wonders. X 2 square, 2 times 2 plus 4 overall 2 plus 3, x is 2. We have 2 square 4, 2 times 2 4 plus 4, 2 plus 3, it is 5. It is 5 means 12 over 5. 12 over 5. 12 over 5 is my answer. And we can go capital root 3x square minus 2x plus 1. 12. Good. We are good to go. Where is the lead? Thank you. Now 12 upon 5 is our answer in that case. We have to avoid overall 0 in the denominator anyhow, if possible. Moving towards question number 4. Limit x tends to 1, x cube minus 3x square plus 3x overall x cube minus x. Question number 4 it is. Limit x tends to 1, x cube minus 3x square plus 3x minus 1 overall x cube minus x Put direct limit in denominator and check. X is 1, x is approaching 1 cube minus 1. So definitely it is 0. Same indeterminate form. We have to avoid this undefined form, indeterminate form by factorizing. Let's check and factorize. Limit x tends to 1. X common, x minus 3, there is nothing common, 3x minus 1. So both brackets are not identical. If you have a closer look on this, it is formula for x minus 1 whole cube. This is identity, x cube minus 3x square plus 3x minus 1 cube. It is identity. Overall, taking x common from the denominator, we have x square minus 1. Limit x tends to 1, x minus 1 whole cube, it is x, still factorize, x minus 1 and x plus 1. X minus 1 whole cube, there is x minus 1. What remains in the numerator? X minus 1 whole square. Overall x times x plus 1. I have limit x times x tends to 1, x minus 1 whole square, overall x and x plus 1. Put limit 1 times 1 plus 1, 2. Denominator is not 0, it's around. So 1 times 1 plus 1, overall 1 minus 1 whole square. So it's 0 square over 1 times 2. 0 over 2, 0 is our answer. We can afford 0 in the numerator but not in denominator, because division with 0 is not allowed in mathematics. It will give us nothing. It is undefined form. It is indeterminate form. Whenever you divide any quantity by 0, calculator or any computer will give you syntax error. Syntax error means it is not possible. Okay. There is another. If you are not in a position to direct guess or deduct it is whole cube formula, then shuffle the data. Still you can factorize like this. Let me give you editor method. They are equivalent mathematically. Let me write x cube minus 1. These two together and minus 3x square plus 3x, overall x cube minus x. Factorize a cube minus b cube, take minus 3x common, here common, and so on. We have already checked denominator is 0 in that case. If it x tends to 1, it can be written as x cube minus 1 cube. Minus 3x common, what remains? X minus 1. Overall x common, we have x square minus 1. Apply cube type formula. Limit x tends to 1. We have first bracket without cube, x minus 1, square of first, change symbol, first into second, square of second. This one remains same, minus 3x times x minus 1, overall x, still we can split this one, factorize by difference of 2 square, x plus 1 as well as x minus 1. Look at this x minus 1 is overall common. This x minus 1 is overall common. What we have left with, limit x tends to 1, x minus 1 is common. What remains? Complete bracket, x square plus x plus 1. Here remains minus 3x. Overall, x times x plus 1, x minus 1. This bracket will be cancelled with this one. So we have limit x tends to 1. What remains? X square plus x minus 3x. It will become minus 2x. Overall 1. X times x plus 1. Put limit. It will become 1 times 1 plus 1. That is 1 square minus 2 times 1 plus 1. Overall 1 times 1 plus 1. Now I have 1 minus 2 plus 1, overall 1 times 2. They are cancelled out, positive 2 and negative 2. 0 over 2, 0 is the answer as we have already calculated. If you are not in a position to have a glimpse, it is a cube type, overall cube x minus 1 whole cube, then try to arranging the order and taking something common are these two miraculous steps in mathematics. When you got stuck, try to take common or arrange. Okay, moving towards further. Question number 5, I think. Limit x tends to minus 1, x cube plus x square divided by x square minus 1. In case of limits having any real number 1, 2, 3, pi over 2, put direct limit. If denominator is not 0, then it's our answer. For infinity, we have 2 to 3 strategies to be discussed later as the situation demands. Here, question number 5. Limit x tends to minus 1. I have x cube plus x square overall x square minus 1. Look at this, just only check denominator. If it is not overall 0, then it's our answer. Limit is 1 minus 1 square minus 1 means 1 minus 1 denominator is 0. Same indeterminate form. Indeterminate form. Avoid it, taking something common from the numerator. Just factorizing, simple factorization, x square common. I have x square times x plus 1. Difference of 2 square, a square minus b square situation. There is x plus 1 as well as x minus 1 cancelled out. I have limit x tends to minus 1, x square overall x minus 1. Put limit minus 1 square minus 1 minus 1. Limit x tends to minus 1. Minus 1. Square of negative 1 is positive 1. Overall minus 1 minus 1 minus 2. Minus 1 over 2 is overall answer in that case. We have to avoid 0 in the denominator. First and final strategy to evaluate limit having any number 1, 2, 3, 0, pi over 2, whatever the case is. If infinity is handled later when the situation props up. For number, it is tremendous. 6. Question number 2, part number 6. Limit x tends to 4, 2x cube minus 32, overall x cube minus 4x square. Mark my words. Limit x tends to 4. Just put 4 in the denominator and check. 4 cube minus 4 times 4 square means we have 4 times cube 64, 16 times 4 it is also 64. Denominator is 0. Indeterminate form, we have to avoid this by factorization in that case. Indeterminate form. Taking 2 common from the numerator, I have 2 common, x cube minus 2 common, x cube minus 16. What is the data here? Let me check. 2x square minus 32. 2x square minus 32, x cube minus 4x square. Bingo. Now we are in a position to factorize. There is x square. 2 common, x square minus 16. X square is common. We have x minus 4. Still you can put limit. 4 minus 4, 0. Difference of 2 square situation prevails here. Just handle this. Something got cancelled out. And we have smooth sailing then. X square instead of 16, 4 square. X square times x minus 4. Factorize this one. First positive or the negative, we have 2 times x plus 4, x minus 4, overall x square x minus 4. Cancelled out. What remains? Limit x tends to 4. We have 2 times x plus 4 divided by x square. Put limit. X is 4, 4 square 16. Denominator is not 0. Just put 2 times x is 4, 4 plus 4, overall 4 square. 2 times 4 plus 4, 8. Square of 4 is 16. 2 8 is 16, overall 16. 1 is the answer in that case. 1 is the answer in that case. Okay. As we move along, the good questions, the questions mostly present in entrance test as well as exam, they are coming now. We are in a good vicinity of a limit. It's a wonderful one. Question number 8 of part number 8 of question number 2. Limit x tends to, we have square root x minus square root 2, overall x minus 2. our slogan remains same. Let me chant the same slogan. Evaluate limit only in denominator. If denominator overall 0, try to avoid it. If denominator is not 0 in case of a real number limit, real number 1, 2, 3, 5, 5 over 2, then it's our answer. Check here. 2 minus 2. 2 minus 2, it's 0. We have to avoid this one. Same indeterminate form. Denominator is 0. Indeterminate form, undefined form. Okay, here first traditional method, after looking at the square root, at you jump to the conclusion, rationalize. Go ahead, rationalize. Change the middle symbol, multiply and divide. Root x plus root 2 divided by root x plus root 2. Now, whenever you rationalize, difference of two situation prevails and you have to work in retrospective fashion. Instead of a square minus b square, you have to write a minus b, a plus b. But in that case, a minus b, a plus b can be merged into a single bracket, a square minus b square. Same situation here. Two bracket a minus b, a plus b. It is tantamount e square minus root 2 square. Here is root x, b is root 2. Overall, x minus 2 times root x plus root 2. Square and root cancelled out, square and root cancelled out. We have limit x tends to, we have x minus 2. Overall, x minus 2 times root x plus root 2. Cancelled out. What do we have? Left with 1 over root x plus root 2. Put limit root 2 plus root 2, it's 2 root under root 2. So it is not 0, it's our answer. X means 2 under root 2. Here it is 1 time under root 2 plus 1 time under root 2, 2 times under root 2. Or take under root 2 common, 1 plus 1, it's 2 under root 2. We have under root 2 times under root 2 plus 1 times under root 2, 2 times under root 2, it's our answer. Or one can rationalize the denominator as it will become root 2 over 4 after rationalization, just as this 1 over 2 under root 2 divide and multiply by under root 2. We have root 2, there is a pair of 2, 2 times 2, it's root 2 divided by 4, that I have written for you. Either this or this as the situation demands. You must be familiar from both. Moving towards next question. This can be done in another fashion. All of a sudden the light went out. We are commencing where we have left. Let me refresh this questions. Question number 7 of part number 7 of question number 2. Limit x root x minus root 2 x minus 2. We have solved this question by rationalization. Now let's see another way out for this. Limit x tends to root x minus root 2 overall x minus 2. We have already checked. Put x is equal to 2 minus 2. It is undefined form, indeterminate. Here, instead of rationalizing, we can adopt this strategy. This x minus 2 is fit for applying difference of 2 square in that fashion. Instead of x, I can write root x square, and 2 can be written as root 2 square. Square of root x is x, square of root 2 is 2, fit for difference of 2 squares. Limit x tends to, we have root x minus root 2. Yes, difference of 2 square situation, root x minus root 2, positive, another bracket is root x minus root 2. Cancelled out. What I have left with, limit x tends to 2, 1 over root x plus root 2. Now put x is equal to root 2 plus root 2. There is no more 0 in the denominator and we are arrive at the result. Under root 2 plus under root 2, 2 times under root 2, 1 over 2 times under root 2 as we have calculated by rationalization. Question number next, also fit case for rationalization. limit h tends to 0, put h is equal to 0, denominator is 0. Let me check for you once again. Part number 8. Limit h tends to 0, root square root x plus h minus root h. Overall, there is x, there is h. So, h is equal to 0. For direct limit, denominator is 0. It is indeterminate form. Indeterminate form. By rationalization, limit h tends to 0. Root x plus h minus root x overall h. Overall h it is. Divide and multiply by changing the symbol. Root x plus h plus root x divided by, that is x. Root x plus h plus root x. Whenever you rationalize, difference of two square situation pops up. A minus b, a plus b, it is equal to a square minus b square. Merging the two brackets, limit h tends to 0. We have root x plus h whole square minus root x square. Overall, there is h times root x plus h plus x. Square and root cancel, square under root cancel. We have limit h tends to 0. X plus h minus x overall h, root x plus h plus root x. Cancelled out. Cancelled out. We have left with limit h tends to 0. H over h times root x plus h, root x. Cancelled out. Put limit here. We have 1 over root x plus 0 plus root x. We are 1 over 2 under root x. 1 over 2 under root x. Under root x plus under root x, it will become 1 over 2 under root x. It is our answer in that case. It is our answer in that case. They are almost identical. Replica, rationalize. Here, it's a good question. Good question. It has 2 to 3 methods. Whether you apply synthetic division. Let me open this up for you. Or you can suppose it's a really good one. Limit, part number 9 of question number 2, limit x tends to a, x raised n minus a raised n divided by x raised m minus a raised m. Check the denominator. Put x is equal to a raised m minus a raised m. Cancelled out. It is indeterminate form. Indeterminate form. Try to remove this. Try to remove this. From this, x is equal to a is the factor of this one. Divide both quantities by x minus a, or one can suppose, take supposition out of box solution. Suppose our old variable x is equal to limit plus new variable. Suppose old variable is equal to x is equal to a plus y, such that y tends to 0. Y tends to 0. If I put y 0, then I am going to x is equal to a. X is equal to a. The same limit. The same limit. Now do this transition. Limit is our y tends to 0, and instead of x, switch over, plug in a plus y. A plus y. Then we are in a position to apply binomial. Just take 2 to 3 terms, and everything works wonder. Now our limit is going to be limit y tends to 0. Instead of x, put a plus y. This one is intact, a raised n overall. Same situation with a little bit variation of the power, a plus y. X is equal to a plus y raised m minus a power m. Apply binomial expansion to write 2-3 terms from the beginning and the end. Limit y tends to 0. Applying binomial, it will become a raised n plus n times a, n minus 1 times y overall 1, r1 factorial plus n minus 1. Now subtract 2 y raised to overall 1 into 2 or 2 factorial and dash dash. The final term must be y raised n. This one same minus a raised to n. Overall, same situation in the denominator. Instead of n, we have tried just m. It will become a raised m plus m minus 1 times y by applying binomial plus m times m minus 1 a raised m minus 2 y raised to overall 1 into 2 plus dash dash 3 dots standard dots to show continuity y raised m minus a raised m. Look, negative a raised n, positive a raised n cancel, positive a raised m, negative a raised m cancel. Right, whatever we are left with. Limit y tends to 0. We have n times a raised n minus 1 times y plus n times n minus 1 a raised n minus 2 y square 1 times 2 is 2 plus dash dash up to y raised n. Similarly, in the denominator, instead of n, we have just y. We have just m, sorry, m a raised m minus 1 times y plus m minus 1 a raised m minus 2 y square overall 2 plus dash dash dash, we have y raised m. Check the situation, limit is 0, 0, there is y square, y cube and so on. Still our overall denominator is 0. Overall our denominator is 0. 0. So then we are not in a position to apply limit. If we take y common, our situation improves. If we take y common from both numerator and denominator, our situation improves. Our situation improves in this case. Limit y tends to na, n minus 1, y and so on. Taking y common, limit y tends to 0, we have y common. What we are left with, na, n minus 1. We have taken y common. Y gone, y square means y plus n times n minus 1 a raised n minus 2. Now we have y because we have taken y common plus dash dash dash. Eventually we have taken y common. Y common means y power 1 means n minus 1. We have to subtract the powers. Similarly, y common from the denominator, we have m times a minus m plus m times m minus 1 a raised m minus 2. We have taken y common, y gone. So divide with y here, divide with y square divided by y, it will become y plus dash dash dash. Similarly, y power m divided by y, it will become y raised m minus 1. Bingo, cancelled out. If we put limit, there is y 0 0 and overall 0 0 0 0. Just these two terms are independent of y. These two terms are independent of y. Put y is equal to 0 0 0 overall 0. These two terms are our final answer. Na raised n minus 1 overall ma raised m minus 1. Bases are same. We can merge the powers n over m. Here a raised n minus 1 times, this one can be written in the denominator as a raised minus m plus 1. Bases are same, they are multiplication at the powers. Finally, eventually we have n raised m, a raised n minus 1 minus m plus 1. Cancelled out. We have n raised m, a raised n minus m is our final answer in that case. Final answer in this case. The same question is handled by the division method, as after putting x is equal to the denominator vanishes, x is equal to a is the common factor of both of these. It is also a tedious one. It is out of box solution that I have mentioned. Hospital rule, it is a later matter for entrance test as MCQ type we can apply. Otherwise, we should have a subjective strategy to negotiate such type of questions. Now, I have done with 1.3. I have done first two questions, then trigonometric functions limit and infinity cases to be handled in the next frame. So, taking the liberty of this space, tiny time. I am here to refresh revision from 1.1 even and odd questions. One I have selected from somewhere special. The rest belongs to the second year question. First one question, a humongous question. E raised x minus 1 overall e power x plus 1. Let's check whether this is even or odd. Even or odd. Let me rephrase the definition. Replace x by minus x if the symbol of overall function changes. This is the definition of odd function. Number one. Number two, if we replace x by x, no transition, no change, then function is even. If the situation is somewhere between changing and not changing, it is neither even nor odd. Let's see this question. Replace x by minus x. Replace x by minus x. It is e raised minus x minus 1. Overall e raised negative x plus 1. How to negotiate, how to sell further? It's really very easy. Make the exponent positive, make the power positive by writing in 1 over e power x, 1 over e power x. And our journey continues. 1 over e raised positive x minus 1 overall 1 raised e power x plus 1. Taking LCM in both situations, we have 1 minus e raised x overall e raised x. Here, same LCM, e raised x LCM, 1 plus e raised x cancelled out. What we are left with, sorry, we are checking even and odd. I have 1 minus e raised x, 1 plus e raised x. In case of positive sign, I can write e power x plus 1 or 1 plus, it's okay. In the denominator, that's why it is taking only minus common from the numerator, and our situation become transparent enough to judge whether this function is even or odd. Taking minus common, we have e raised x minus 1 overall. It can be written in the same fashion, e raised x plus 1. I have taken minus common from the numerator. Taking minus common from the numerator, taking common from the minus numerator, and taking minus common is something wonderful in mathematics. So it is overall same function, and there is negative symbol, negative f of x. So f of minus x is equal to negative time f of x. It is the definition of odd function. So this is our odd function. 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 The rest we have already done. Let me compile for you as well. So check, this one is even or odd. Replace x by minus x. We have minus x raised cube minus x. Power is odd, minus retained, minus x cube. Taking look at this, there's overall both terms are positive, there are negative. It's enough for us to decide function is odd. Or by definition, taking negative symbol common, x cube plus x. That is the same or function f of x. There's inclusion of negative symbol. So f of minus x is equal to negative time f of x. It is definition of odd function. So this is our odd function. This is our odd function. This is our odd function. Another one that is x plus 2 square. F of x is equal to x plus 2 whole square. Replace x by minus x plus 2 overall square. If I take minus common, at most it will become x minus 2 overall square. This minus by the virtue of even power turned to be positive, but x minus 2 whole square is my result. Here there is x plus 2 whole square, there is x minus 2. It is neither same nor completely changed symbol wise. It's neither same nor completely changed by symbol wise. It is somewhere between. It is somewhere between. So it is neither even nor odd. Neither even nor odd. It is neither even nor odd. Look at it. It is somewhere in between. Somewhere in between. We have x plus 2. Either both are negative or both remain same. That is not the case in that case. X is same while 2 has changed the symbol. It is neither even nor odd. Neither even nor odd. Another good question, that is f of x is equal to x times root x square plus 5. It's good one. Replace x by minus x to check whether it is even or odd. Minus x square plus 5. Power is even, negative will be turned to positive. There is x square plus 5. Look at this. Overall positive, that is overall function, but inclusion of negative symbol, it will become negative times f of x. F of minus x is equal to negative times f of x. So function is odd. Function is odd. So this function is odd. This function is odd. Let's move to question number 5. That is x minus 1 over x plus 1. F of x, that's x minus 1 over all x plus 1. Replace x by minus x and check minus x plus 1. At most, we take minus common from both numerator and denominator. What happens? Let's see. Negative common, it will become x plus 1. Negative common, it will become x minus 1. Minus minus cancel. So we have x plus 1, x minus 1. It is, they are multiplicative inverse of each other. It neither remains same nor completely symbol changes. It is neither even nor odd function. Neither even nor odd function. It's neither even nor odd. It's a good question having fraction power. It's a good question having fraction power. How to decide a power having fraction in power? It is even or odd. F of x, x raised to 2 plus 3 is equal to 6. Replace x by minus x raised to 2 over 3. 2 over 3. Our decisive factor is numerator. Numerator of the fraction. Numerator of the, look at this. It is even. This fraction works like even. If it is odd, then it works like odd. Let me give you mathematical idea about this. Negative time x raised 1 over 3 overall square plus 6. Now look at this. We have two possibilities. Either minus intact or it can be turned into positive. If minus is intact, owing to virtue of square, even power, it can turn to be positive. If it is positive, then it remains positive. In both cases, whether negative remains or vanishes. Owing to this even power, it will be turned to positive. Here it is 1. Here it is 1. It is odd power, minus remains. Owing to this even power, it will be turned into positive. So we have positive x raised 1 over 3 overall square plus 6. So it is x power having another power, multiply the powers 1 upon 3 times 2, 2 over 3 plus 6. It will remain same. So the function is even. Let me emphasize stress upon this part. In fraction, numerator part is decisive factor. If it is even, then this fraction works like even. If it is odd, then fraction works like odd. Here, numerator part is even, so this fraction works as even. It turned negative into positive. Owing to the virtue of this even character. That's why this function is even. Last but not least, final question. That's a mixture of first one and having denominator something. For one can inspect that it is odd function. Let's check how. F of x is equal to x cube minus x overall x square plus 1. Replace x by minus x to check even or odd. Minus x cube minus time minus x overall minus x square plus 1. Power is odd, minus remains, minus x cube. Minus plus x. Owing to the even power, minus will turn to be positive x square plus 1. Taking minus common, the situation is statins, x cube minus x overall x square plus 1. Look, function is completely present with a negative sign. So it is negative f of x, negative f of x. So f of minus x is negative times f of x. That is the definition of odd function. That is the definition of odd function. So this function is, or this function is odd. Reveal from 1.1, golden question, mostly present in exams, entrance tests, base making. By becoming aware of the definition, good questions, and what is coming next from in the form of trigonometric and infinity, they are humongous limits, humongous limits. It's my tiny effort to you second year students to guide you through what is calculus or beginning of calculus. It's all by itself. Next.